Okay, we'll go ahead and get started here and welcome everyone to our webinar today on NXCam. I'll go ahead and just cover our presenters and an agenda for today. So my name is Paul Stevens. I'm a Division Sales Director for Maya. And my colleague here is Andy Schaefers. He's a Senior Application Engineer and has been working with NXCam for decades. And so I'll just cover briefly our agenda for today. I'm going to introduce Maya, and then I'll go ahead and do a short introduction of NXCam, and then we'll dive in today's topic, which is surface finish improvement in NX. And then we'll do a summary and have some time for questions at the end. So also, we do have some polling questions we'll put out there at some point during the presentation, and at the end of it, there will be a survey that you can take when we're all finished. So Maya is a leading software developer and engineering services provider. We help clients and partners worldwide boost performance, improve quality, and drive down costs by reducing inefficiencies and harnessing the business value of your data. We've got offices in the US, Canada, and the UK. And we provide products, some of those we develop ourselves, some of them are from Siemens, that cover the spectrum of your product lifecycle, from design and simulation to manufacturing. We do industrial IoT and applied AI products. We do custom software development, automation and optimization, and product lifecycle management. So just a brief introduction to NX for manufacturing. NX provides design and optimization for additive manufacturing and 3D printing. We of course sell NXCam for CNC programming, and that's what we'll cover today in the topic. We cover the use of NXCAD to program using the digital twin of the entire job shop. NX for CMM inspection to control part quality, utilize PMI data from the NXCAD model, design tooling, fixture design in the same environment, and we cover shop floor integration for revision control, QMS compliance, and efficient work instructions. So today's topic is surface finish improvement in NXCam, and Andy's going to cover topics ranging from path, smoothing capabilities, circle segment tool support, node alignment, smooth tool lifts, steep, non-steep machining, blend machining, and deburr operations. So with that, Andy, I'll go ahead and pass it on to you.
Great, Paul, thank you. Okay, Paul, just a quick check. Can you see my presentation screen?
Yes.
Excellent, thank you. We're going to start with smooth paths using our newer guiding curve command. And on the screen, you see two pictures that differentiate the two uses for this command. On the left side is what we call morphing, and that's a situation where we want a smooth path at both edges of our surface that we're machining. And you can see the way we do that with morphing. On the left side of that image, the step over is reasonably large, but of course at the other side, to make that all work out, the step over decreases in size. Now the other type of machining we want to do with the guiding curve is a constant offset. So you see that in use here on the picture on the right, where we have got a constant offset coming down from this single control curve. And of course, as we get down lower here, there are different widths. And so the tool runs out. And at that point, then we're going to pick up and go over and start the toolpath again. What you'll see as we go through the demo here in a minute is that there really aren't many user inputs required to get great results from this command, and that it's effective even on very complex geometry or a large number of surfaces. Let's demonstrate that now in NX. For our first example, we'd like to machine the shelf area of the mold, and we'll use a fixed offset option with our guiding curves command to get that result. Let's look inside so we can see how few parameters actually need to be set to get the result that you're seeing here on the screen. Here's my geometry setup, and because it's a constant offset, I only need to select a curve up at the top. So in other words, there's just the one guiding curve. Then down here, I'm setting some parameters for the pattern type, and in this case, it's zig. This is a hard material, and I want to make sure that I'm always climb cutting. So you can see that as it gets to the end, then we're making a tangent move outboard, picking the tool up to a safe location, and then returning back to the beginning again. Also, because it's a constant offset, it may run out at different places along this shelf, and you can see the rapid moves moving along as that width changes. Again, it's doing that in a smooth and rational way. Now, what about the surfaces themselves? Well, I've just picked the entire part, and then for a cut area, I've just grabbed all those surfaces that make up the shelf. That's all that's needed to make the guiding curves work in this case. Now there's a second example here also that's really doing the same thing, but I wanted to show you how smart it is about handling the rapid moves. Down here where there's a fairly wide area between a pickup and an engage, you see it's moving to a safe location, rapiding across, and then doing the engage. As you get to a shorter distance, it's still doing a rapid traverse, but now it's doing a tangent move, so it's not returning to some Z-plane, it's just doing more of a direct motion to get back to the beginning. And for an even shorter distance, there is no rapid. It's using the green step over feed rate to just quickly feed back to the beginning and do the next path. And that's all happening automatically in the algorithm. Now we're going to look at another use for the guiding curves command. We just looked at offset, which when it ran out on an edge, just rapided back to the beginning again. Now we're going to look at morphing, where we want to start with a smooth pass on one edge and then finish with a smooth path on the other edge, and we'll vary the offset in order to maintain that smooth toolpath that we're looking for. So here we are with zigzag, and I would like to jump in real quick and just show you how few parameters are required to set this up again. In this case, I do have two curves to select, guide curve 1 here and then guide curve 2 here. And again, it's just morphing between those two. I'm using a zigzag pattern, and I've specified a maximum distance for that offset, but it can go smaller than that as necessary to give me the smooth toolpath that I'm looking for. You'll notice that this cavity is not made up of a single solid. There were some slots cut in it, and the way I dealt with that was I used the patch openings command to create the patching surfaces, and then the guiding curves has no problem making a smooth toolpath across all that. Okay, here's some other options then once we get that going. So here's zig, where again I'm doing a tangent retract and a tangent engage at the other end. And then here's zigzag outside in alternate, which is another option. And then outside in alternate with the opposite guide, so you can change the direction on how that's going to work. And here I'm doing moving away from morphing now and just doing a race track around the guide. That's nice if you just have a small area that needs to be cleaned up. And here I'm using a defined area. And again, I'll go into the parameters and show you that it's really not much to set this up. Here with the guiding curve options, I have two curves, and you'll see then that it's not necessary that those curves belong to the surface or solid edges. They can just be arbitrarily curves that you've created. And this time I'm using a cut pattern of helical, so it just spirals its way all the way to the inside. again, using that maximum distance. So even though the distance across is not always the same, I'm going to get a smooth toolpath by morphing that offset distance to achieve the smooth toolpath at both ends. Okay, that's our guiding curves command using the morphing option. Paul, could we kick off our first poll question, please?
Yes.
Okay, we're just looking at the types of materials you guys are mainly machining. And it looks like so far no votes for hard metals like titanium or Inconel, which are a huge challenge. But certainly the non-ferrous materials and the plastics also present their own challenges. Even though you're moving quickly, you still need a good surface finish. Let's take that as a segue into our next topic then, the circle, segment, or tangent barrel tools. If you're familiar with these, they've actually been around for many years, but recently are becoming more popular. And I think the main reason for that is the proliferation of these trunnion-style 5-axis machines, where you can now easily orient your tool to a surface. That was always the issue with these tools, is that they are very sensitive to the relative angle between the tool axis and the surface normal vector. But what they essentially do then is approximate the surface finish of a much larger tool by using a very large radius on that conical feature, even though it's really effectively just a small diameter tool. Let's look at a quick demo of how these tools can benefit you. To demonstrate the benefits of these circle segment or tangent barrel tools in NX, I'm using a model of an impeller, and I need to finish machine one of these faces here. Let's look at the geometry of the tool itself and how it's set up. You'll find that the entries from the tooling catalogs map nicely to the way we've defined the tools in NX. And you can certainly see the curvature here. That's 95 millimeter radius. So I'm simulating the finish of this much larger radius tool with a tool that has itself a 6 millimeter diameter. And it does have a 1 millimeter radius here at the bottom. Okay, in this operation then, you can see that I've got a number of finish passes here. And probably the most interesting part of the parameters is the way the axis is set up. So if I click here, you can see, again, the issue is you want to make sure that your cutting stays up on the tangent barrel area of the tool, not down on the radius, and it's behaving just like a ball end mill. And so in this case, I'm using a swarf drive to orient my tool with a 10.5 degree tilt angle. So it's a very easy way to set up your tools. It just looks at the angle locally of the surface and then the center line of the tool and drives it with a 10.5 degree angle there. Okay, at this point then let's do a verification so that you can see the material removed by this tool. Okay, here's my vane with finished stock remaining. Let's run the simulation here. And I think you'll see that even with the large step over, we're getting a really nice cleanup. If you haven't considered them before, the circle segment tools along with NX Cam for finishing can really improve your productivity and surface finish for your production parts. Okay, let's move on. Okay, Paul, let's kick off that second poll question, please.
Okay.
We're looking now for the machine type you guys are using, or at least the machine type that you're more interested in using for surface finish improvement. And it looks like we're coming up with 5-axis mills, and that is pretty typical. Okay, let's move on to our next topic, which is node alignment. And I'm going to start with some definitions here. If what you're looking at on the screen is just an approximation of a surface. So you've got the bold blue line in the middle represents our surface. And then in the light blue, I've got a ball end mill that I'm using to machine this part with. So what are the dashed lines around the outside of that? That represents our in tall and out tall state. So we have a tolerance that we're machining to. We can go inside the surface just a little bit, or we can stay outside the surface just a little bit, and our part will still meet requirements. So to machine this surface, then we're going to take that in tall and out tall information, and we're going to apply a series of straight lines, which you see here in green. And as long as those lines stay inside the in tall, out tall, we're meeting the tolerance requirements of machining that surface. The corners that you see here are the nodes. So the question is, what happens if this is a zigzag toolpath and I've zigged over to the right and now I'm coming back the other direction? And it looks like this in red. The red is also a valid toolpath. As you can see, it does not violate the in tall or out tall. However, if we look at localized areas like this one right here, we can see that the out tall state in red is just adjacent to the in tall state in green. When we look at that situation over an entire surface, we'll notice it as a rough surface finish. We can imagine, though, we would improve the surface finish if we could take this red path and shift all those nodes over to the right a little bit so they lined up with the green nodes. That's what node alignment does, and it happens automatically for you in all of our finish routines in NX. Let's go through a quick demo in the software. Here's the part that I'll use to demonstrate the aligned nodes function. There's a single operation here. It's an area mill, so it's a 3-axis contour, and I'm using a ball end mill. Let's go inside the operation itself. I'd like to show you some of the parameters that were used to set this up. The first thing you'll notice here is it is a zigzag toolpath, and there's no smoothing here in the corners. I am using the steep, non-steep setting, but everything here is non-steep. So these are the parameters then that would be used to set this up. Probably more importantly, though, is the in-tall, out-tall tolerance. So we can define this ourselves. And although it's quite large right now, I'm going to make it even a little bit bigger just so it's easier for you to visualize the aligned nodes. Okay, there's our updated toolpath. And now I'll turn on the display of the endpoints of the toolpath. And then as we start zooming in, you can really see the effect or impact of those aligned nodes. As anywhere that's possible, you can see it's done a nice job of aligning all those adjacent nodes to each other. And again, that has a significant impact on surface finish. Our next topic is smooth tool lifts. This is a technique that can really improve your surface finish when you're using a zigzag type tool path. We want to keep those turnarounds off the part slightly if we can. However, we'd also like to keep the tool path tangent at all points as we move around so that in our high-speed machines, we can keep the feed rate up. Now, the smooth tool lifts are not just some individual operation that you choose in NX. It's actually a capability that's added to all of our finishing routines that can do a zigzag toolpath. So it's broadly available to you when you need it. Again, let's demonstrate that in NX now. Here's the part that we'll use to demonstrate our lifts on stepovers here. And you can see the problem. I'm not machining all the faces on this part. So these turnarounds here are going to potentially leave a divot on the surface that's going to be hard to clean out with hand finishing. So let's make a couple changes and solve this problem. I'm diving into the area mill dialog box, and I need to basically just change two things. Here in main, I'm going to change the non-steep cut pattern from zigzag to zigzag with lifts. Let's hit the generate button and we'll quickly see that in fact that does give us a lift off the part and it's tangent, so it probably solves our problem. And if we wanted to, we could change the angle of this radius or the value of the radius itself. But what we'd really like is just a nice smooth turnaround that just barely lifts off the part. So that's step two. Here we're going to go to our non-cutting moves and we can fix this just by hitting the check mark. So we turn the smoothing on, regenerate, and just like that, then we've got those smooth turnarounds, and you can see the height is 15% of my tool diameter, so that's how far it's lifting. Now there's also a max step over that you see here, and that's what's causing these moves on the acute edge to get longer, and then it's putting a traverse in instead of a step over. But we could fix that here if we just change this to 200%, regenerate one more time, and now we've got the feed moves everywhere. So that then is our step overs with lifts on zigzag moves. You'll see this technology used throughout NX CAM. It's fundamental to how we create our finishing passes. Our next topic is steep and non-steep finishing. This is a challenge that's faced by many programmers. When you have complex organic geometry, this can be aerospace parts, or it's often commonly encountered in molds. And what we need to be able to do as programmers is differentiate the steep and non-steep areas into regions. And the reason is that each region type, steep or non-steep, is going to have a more effective cutting toolpath. As you see here in the image, around the outside, we're using a zig toolpath, but as we get up on top, we're doing more of a periphery move to work our way inward. And then we want to be able to make a smooth transition between those regions. Let's look at how NX helps you do that. We'd like to create a finish pass for the handle area of this hairdryer mold. Our part surfaces are in purple, plus there's some areas where there were ribs and bosses, and I've used patch openings to create a surface that we can bridge across. Here in the dialog box for our area mill command, we can see the instructions that we're giving NX CAM to tell it how we want to machine this. For instance, here's a steep angle that divides the steep and non-steep. Then the instructions for non-steep, we're going to do follow periphery and work inward. For steep areas, we're going to use Z-level zig, although there are several other options we could choose from. Now let's go to the geometry view, and this is the part where we actually tell NX CAM to do the divide on that 60-degree angle. We create some regions. Just takes a few seconds and those are returned to us. So we can see in blue the non-steep, and here in purple is the steep area. But we notice it found a very small steep area here in the middle, and that's designated by this area region. We'd probably like to just machine that as a non-steep. So here's how we do that. I'm going to edit it, and then I can just tell NX, hey, that's going to be a non-steep area. The next thing to do is merge that, and we'll just merge it in with the other non-steep area. And once we do that, you'll see that it's just one continuous area going across there. Really nice feature for manually overriding that steep, non-steep decision that it's made. Okay, at this point, we just need to generate our toolpath to see the result of this finish pass. And we see that we've got, again, a nice Z-level zig down at the steep areas with our tangent engages and retracts, and then the periphery move up on the top, creating a really nice finish pass on this mold. Hey, Paul, let's kick off our third pull if we could.
Okay.
Just questioning here what your secondary goals are for improving your surface finish. And it looks like maximizing the output of less skilled workers. That's certainly an issue we hear a lot about now. It's tough to find people, and anything we can do on the machine to improve surface finish, reduce the load on hand finishing later on is usually a benefit to us. And also a response for reducing time to program the parts. That's certainly one of the objectives we have in our development of NX-CAM. All right, we'll close that poll and continue. Excuse me. Blend finishing is really just a special case of other finishing type operations. And as we show this to you, you'll certainly see lots of similarities. But there are a couple of special situations that are encountered in blend finishing and that we accommodate through special capabilities in NX. First, our users want to automatically identify blends in a part. We can do that in a couple of ways. We can either find the concave areas as you're seeing here on the screen, or we can use a reference tool, which means essentially, say I have a 3/4 inch ball end mill as a reference tool, and then I'm machining with a 1/2 inch ball end mill. What I'm saying is I want to machine everything that 3/4 ball could not reach. So that's one of our capabilities that we add. And another is that even in a situation like you see here with the sharp corner, your ball end mill could dive right in, do a 90-degree turn and come out again. That's often going to chatter, especially in hard materials. So you can see here that we've contrived a blend radius to add to it so that tool doesn't come to that hard stop and change direction. Let's go and look at some of these capabilities in NX now. Okay, here's an example using our flow cut technology. And the first thing you'll see is that we're working off of sharp edges. In other words, the fillets and rounds are not modeled here. The command does just fine with either situation. As with some of the other examples, I've got a really coarse step over just to make it easier to see what's going on. And as a review then, we've already talked about our ability to do non-steep and steep cutting and split that up in the same operation. And you're seeing that here also. So all these moves down here and going down this shallow angle, those are all controlled by the non-steep. So you're getting this Z-level zigzag, whereas the steep cutting is a cross-cut zigzag with lifts in this case. And we talked about this earlier, but the lifts mean that on these green traverse moves here, it's popping up just a little bit above the surface. Okay, so what if we were cutting a harder material then? This particular toolpath might be a problem for us because of the zigzag that we're doing here, where you're doing both climb and conventional cutting. So let's look at another set of operation parameters that would solve that. This is the same command, it's still flow cut, but we've just adjusted a few things. And now we've got, we're always climb cutting, and we're doing the smooth transition back to the beginning again. A really nice tool path. Okay, one final thing though that we might want to change is the fact that we've got a tool that can fit completely into our corner here. In other words, I don't have a fillet designated here that has a larger radius than my tool radius, so I do see the sharp 90-degree corner. Well, in that situation, even though the tool does go into the corner, you might not want that. So here I've made one more change to that operation type. So it's the same tool, same geometry, but now I'm saying, look, I don't want you to go into that corner. Let's make a nice smooth transition around there. So if you were cutting hard material, this flow cut operation would give you the options to do this in a productive manner and still give you a nice surface finish to work with. Here's our last topic of the day. It's deburring, and traditionally this wouldn't be included in a discussion of surface finish on milling machines, but we've noticed a lot more interest from our customers in the last couple of years in deburring. And I think part of that is just because of our the changes we've made to the software. We've got special operations now just for deburring, so it's very quick to program these. And this has changed the way people are starting to think about deburring. It used to be you wanted to get the part off the machine as quickly as possible, get it onto the next part, and then you'd send the part off to hand finishing. Well, you know, it is possible to scrap a part in deburr by going too deep on an edge or something. So particularly with some of these complex geometries, there's a risk in doing that. So I think our addition of these easy to program deburr operations, along with the preponderance now of the 5-axis trunnion machines, has made this really a profitable, productive change for our customers to make. So let's go ahead again and look at what these operations look like inside NX. We'll use the cylinder head to demonstrate our new deburring functions and start with the fixed axis or 3-axis deburring. The setup is very simple for the users. In this case, I've got a port on the backside that's tough to access, but I choose a access direction for my tool, in this case, a spherical ball end mill. And you'll see as I play this that it has no trouble transitioning from cutting on the top of the ball to the bottom of the ball. Here I'll just place the tool in a couple locations so you can see that. Here we're cutting up on the top and then deburring down here on the bottom to smooth that port surface out. Now we'll move over to the 5-axis deburring. And again, here the setup is very simple, although in this case, though, we are letting the tool axis be automatically defined by the operation. So I'll go through one of these slowly so you can see that. And now let's jump over to the larger ports here. So a great technique to quickly achieve smooth deburring, even on these complex parts with complex machine kinematics. While I have the cylinder head up on the screen, let's look at another specialized case of finishing. It's called our tube finish command, and it's similar to some of the other finishing functions that we have in that it does a great job of placing a helical toolpath through the part. But as we play it, you'll see that it understands that its access inside the port is limited, and it will change that tool axis angle as it gets down deeper inside the port. So if you have a finishing operation that requires work on the inside of a tight space like that, our tube finish command might be a great option for you. Okay, here's a quick review. I've shown you that NXCAM is a very effective solution for solving part finishing issues you're having in your shops. We've gone over the solutions that are applied for both your 3-axis mills and your multi-axis mills. And of course, that can also be translated into mill turns if you happen to be using them. And we went over the circle segment tools, showing how we can help you capitalize on the latest tooling technologies that are out there and our commitment to that continued to development. Our plan here is to help you increase your throughput while decreasing the risk of tool chatter in your finishing operations. Overall then, NX-CAM is a solution that you can have confidence in. And for wrapping up our webinar today, I'm going to turn it back to Paul.
Thanks, Andy. If any of you have any questions, you can go ahead and put those into the panel here. Just type them in and we can answer those for you. Okay, well, doesn't look like we have any questions. Here's a little bit on Andy's contact information if any of you have questions later on and want to reach out. Andy can be reached at the same email address, andrew.schafers@mayasim.com. And then, of course, our Twitter handle and LinkedIn for Maya. Please take some time to take a look at those. And of course, we've got other webinars. Take a look at those on our website. And if there's no questions, I think we'll go ahead and wrap up. There should be a survey that you can take here at the end. So I might leave this up for a few minutes. And if you do have that survey, please fill that out for us. It'd be very helpful. Okay, well, thanks, Andy. Appreciate it.
Yes, thank you, Paul. Thanks everyone for attending.
Yeah.